So in the last video, we talked about measuring the center, either median, if it was skewed, or mean, if it was symmetric. And now we're going to talk about measures of spread, okay? Is the data all really close together? Is it really spread apart? And that's going to be standard deviation. Also interquartile range, which we'll talk about later. So to start with standard deviation, which is the useful one when when we have symmetric data. And hello, October, you're making this a little difficult. We're going to start by showing where it comes from, because there's a lot of really complicated calculations going into the standard deviation. But if you understand kind of where these calculations come from, it should be a lot more instructive, okay? So we're going to start by looking at an example. There's 4 students sitting at a table, and these are their ages, okay? Right off the bat, I'm going to reorder this 19, 19, 22, 36. I'm going to reorder it just so that it's smallest to largest, okay? You don't always have to do that, but you could. So this is skewed data, okay? That 36 is kind of like an outlier. It's going to be skewed. The median and the interquartile range are going to be more useful, but for purposes of talking about standard deviation, let's go through a process to show what standard deviation even is and how to calculate it. So we're going to start with step A, calculate the mean age. So we did this in the last video. X bar is going to be 19 plus another 19 plus 22 plus 36 divided by the total number of students, which is 4. All right, and we can calculate that. Sometimes we're going to be using Google Sheets a little bit in this class, or Excel is also good. You can open Google Sheets. I will post a link to the Google Sheets in the description or near this video. And you can go here, and there's a lot of really useful things. So one of the things that it's useful for is as a calculator if you want. So if you wanted, you could type into one of the parts of the spreadsheet equals, and then you could type in all of those calculations that we did. Parentheses, 19 plus 19 plus 22 plus 36 divided by 4. You need the parentheses so it knows that everything up there is in the numerator. And then it's going to tell you that this is exactly 24. So this right here, the mean age is 24. Okay, that's step 1. Now we need the deviations. How far are all of these ages from the mean? Okay, so the deviations is just X. This is the data value minus X bar, which is the sample mean. Okay, so for each of these, we're going to take X minus X bar. And in fact, let's label it that way. X minus X bar. So X minus X bar is going to be 19 minus 24. 19 minus 24 again, because there's 2 19s. 22 minus 24. And 36 minus 24. So let's simplify that out. That's going to be -5, -5, -2, and 12. And so if we were to do this on a spreadsheet, like Google Sheets or Excel or a different kind of spreadsheet, you could write it like this. Let's make a column for all of our X values. A column for X bar, if we want. And then we could have a column for what is the difference, X minus X bar. Okay, and it would be actually a really great idea if you pause the video right now, pull up an Excel sheet or a Google sheet and do this at the same time as I am, pausing the video to catch up when you need to. All right, because if you're not doing it yourself, it's going to be kind of hard to follow along. But if you're doing it yourself, you have it saved somewhere, and you can learn it a little bit better as we're doing it. So our X values, these are our data values, 19, 19, 22, and 36. The X bar, that's the average. X bar, the average is always 24 for all these data points. So now, if we want to subtract these, just type the equal sign. See how it it's automatically predicting, which is really nice. Click on this cell, subtract this cell like that. Then it automatically subtracts in. See how it automatically, ooh, actually that was really cool. When I did this, right? Do this. And then it automatically did something else. So now what we're gonna do is click this corner bottom box, drag it all down. And this is just another way, -5, -5, -2, and 12, to do exactly what we just did right here, okay? And you might say, well, Jason, that took way longer to do it with a computer than by hand. Don't worry, we'll see why that's going to be useful later. So we found the deviations from the mean for every single data point. Well, we want to talk about distances. And when we talk about distances, having positive numbers is nice. And also squaring things in math in a lot of different ways is nice as well. So we're actually just going to square all of these distances. So that's going to be now 25, because -5 times -5 is positive 25. Another 25. If we square -2, that becomes positive 4. And if we square 12, it becomes 144. But these are all the squares of the distances. These are what we want. This is x minus x bar squared. So in our spreadsheets, we could also do that very, very quickly. Let's put that in the next column, right? Let's have this be x minus x bar squared. Well, then again, we're going to type equals. That's just x minus x bar. So we click on that cell and then square it, just like so. And again, 25, 25, drag that corner box down. And we get the same numbers that we did by hand. Okay, let's keep going. Now we want to average these deviations. So we're going to add them up and divide by n minus 1. And the reason why we add them up and divide by n minus 1 is a little complicated. It has something to do with degrees of freedom. If you want to read a little bit more about that, I have some resources I could give you. But in general, let's not worry about it too much. We're going to add up. We use the sigma for adding up all of them. We're going to add up all of these things that we just calculated, all of these x minus x bars, and divide by the sample size minus 1. This is the variance. And a lot of times it's called sigma squared for population variance, or sometimes s squared for sample variance. And actually, since we're dividing by n minus 1, it's always just going to be s squared for the sample variance. Okay, so let's add up all of these and divide by n minus 1. 25 plus 25 plus 4 plus 144. Just add up all of these, divide by, there are 4 data points, and subtract 1. And we could type that into our calculator. If we're doing that all up here, what we're going to do is actually really, really nice. Let's just add them all up by writing the equal sign, sum parentheses for sum, just click and drag over all of these boxes. And we can add them up just like so. To get the variance, we are going to add up, well, we're just going to take this number that we found, the sum, and take this number and divide it by how many there are, minus 1, which in this case, 4 minus 1 is 3. That's our variance. Our variance is 66. We're going to go tab out, go back to our notes, say this is 66. The variance, which we're going to call s squared, is 66. So the reason why this is squared is because we squared all of this stuff earlier, right? So we kind of want to undo that squaring. So it doesn't undo it perfectly, but we're going to kind of get things at least back in the same ballpark. So we're going to square root this actual answer, and that's going to be what the standard deviation is. It's just measuring how far each individual thing is from the mean, how far everything is from the center, and that's a way of calculating spread. So if I take the square root of this, That's going to be the square root of 66. And again, if we want to do it over here, standard deviation, type equals SQRT, parentheses, click on the variance. It's going to be about 8.12. And this shows the average distance from the mean for our data. So again, if we scroll back up, right? This is our data. What's the average distance, in a sense, from our mean? So if the standard deviation is big, that means things are really far away from the mean on average. It's a measure of spread. If the standard deviation is small, that means things are very close to the mean. Again, a measure of spread. And you can kind of see in how we constructed this, where that standard deviation is coming from. The further you are, like look at this 144, that's where a big bulk of the size of that standard deviation is. If we got rid of this 36 data point, this 144 would go away and our standard deviation would be much smaller. So this is just one way of measuring the spread, and that's standard deviation. So if you have that sheet, I'm going to show you where the real power is with doing something with like a spreadsheet or Google Sheets or something like that. And that's when we go to the next example. All right, so I'm going to introduce a couple of things before going to this next example. And then this next example, that spreadsheet's going to really shine. So again, as I said earlier, if we have symmetric data, mean and standard deviation is good. We don't really use mean and standard deviation for asymmetric data, for skewed data. That's more median interquartile range. IQR is what it's called. That's in a future video, okay? But otherwise, we do use standard deviation. So again, to kind of recap what we did, first, we found all the deviations, how far each individual thing was from the mean. And then we squared it to make it positive. Then we add it all up, divide by n minus 1. That's the standard deviation. And then we, or that's the variance, and then we square rooted it, and that gave the standard deviation. Okay, so this is just kind of summarizing what we did in the last page. So now we could do all of that again, but since we already have the framework set up, let's just type this data, 3, 8, 12, 15, 18. Let's just type this data into our spreadsheet. So we're going to need one extra row. So let me insert a row and then say 3, what were they? 3, 8, 12, 15, 18. We need to still calculate X bar to find that mean. Well, let's use the sheet for that too, right? Let's say the mean, right? The mean is adding up. So that's equals sum, add up all of these, drag that down, and divide by how many there are. There are 5 of them. Okay. The mean is 11.2. So each of these is 11.2. Copy it down again. Take each data point, subtract it from the mean. Let's drag these down. And then take that result and square it, drag it down. Add them all up. They're all getting added up. Divide by how many there are minus 1. N minus 1 in this case is 4. We added an extra data point. And then we take the square root, okay? We get 5.89 is our standard deviation. If we want to change this, well, here, let's write it down, our answer. So normally I do require that you show your work, but if you're doing something on a spreadsheet, you might say, oh, this came from a spreadsheet, or this came from my calculator, this came from GeoGebra. We'll be using GeoGebra in a later video. We're going to get that the standard deviation S is approximately, we are rounding, so we're going to use the approximately sign, 5.89. And again, if we were curious about what if I had an outlier? What if I mistyped 18? What if instead of 18, I typed 181? Look how much bigger the standard deviation gets. It's 85 now, as opposed to 6 about before. Okay, so the standard deviation is greatly affected by outliers. Remember we said the mean was pretty easily affected by outliers? The standard deviation as well is really affected by outliers. So we don't like to use standard deviation when we have outliers or skewed data. All right. So let dataset A represent the number of people visiting a certain cafe on 5 randomly selected days. Describe the center and spread for this dataset given that the data is symmetric. Okay, so given that the data is symmetric, that means we're going to use the mean and the standard deviation. If it's not symmetric, we use median and IQR. So we're going to use that same data, 3, 8, 12, 15, 18. Just going to write it down again so we don't have to scroll up and down. Describe the center and spread. Given that this is the the number of people, so that's discrete values. Discrete is when we can count, whereas continuous was everything in between, but you can't have like 8.3 or something, or 8.3 repeating people. Describe the center and the spread using the context of the problem. So our center was that mean, which is 11.2, right? So our X bar was 11.2. So if we convert that to words, what does that mean? That means the average, or on average, the average number of people at this cafe is about 11. Okay, we're talking about people. You might want to round it to 11, or you could write 11.2. It's up to you. And then you could say that the standard deviation is about 6. So this varies by about 6 people usually. All right, that's kind of one interpretation of the standard deviation. How does it, what's the normal vary? Like, how does it normally vary? That's one way of interpreting this. There's a lot of different answers that you can give here, but this is one way of interpreting the mean, right? Average number of people has to do with the mean. And how does it vary? What's the spread? How does it change? Like, it has to do with the standard deviation. All right. And that's how you calculate the standard deviation. You can do it by hand. You can do it with a spreadsheet, or as we'll get into the technology portion of this subject in the last video of this unit, we'll also talk about how to get it even faster way. All right. Let me know if you have any questions, and good luck.